Legal 218, the Skyline Problem. This question gives us two-dimensional buildings, and let's return the list of these integer, which represent the skyline. So the building have elements have left, right, and heights, which represent a building, right? So it has this point and this point, and this, and also its heights, because all the building have one edge just to the ground, right? So we just use a 3 point. It can represent the building. And let's get those kind of skyline. Let's look at the skyline, right? At the point 3, we'll see at this point, the highest height is 2, right? Is 10. So we need to have it have 210. And at 3, there is the highest is 15, right? And here we'll see at this point, the 15, this kind of point has been moved from our data structure, right? So we need to get the next highest one. So the next highest one is that we have a point entering at a point 7, right? This is 7. 5, right? This is 5 at 5. And when at a 7 point at a point 7, the 15 moved, the highest is 12. So we need to put the 7, 12 into our data structure, right? So intuitively, what we think about is that we put the age for the building, right? There is an entering event and a leaving events, right? So we put those kind of entering events and leaving events to some kind of data structures. And every time for every event happens, there is, for example, T1, right? And here there is another building entering, right? That's T2, right? Every time this is the living event for example, T3. Every time this event happens, we get the highest points in our data structure, right? So intuitively, what we're thinking about is that we can use a heap to use a pick function to get the highest points, right? But the thing is that for example, this building, when for example, this times 3, right? If we use the heap to delete this point, this is not an O n, it's not an O log n time complexity, right? So it is O n time complexity. No matter it is Java or Python, right? Because when we delete with Python, we need to redo heap file. So that will be O n time complexity. So what we're thinking about is that we can use a tree map to substitute the heap, right? But for why we cannot just use tree set, right? Because for tree set, for example, there is 2 points, they have the same height here, right? Same height here. But if there is one edge living, right? If we use tree set, this point has been moved from our data structure. But actually, we need to with the still there is another building has this edge has the same height, right? So we cannot just use tree set. We need a tree set and tree map and to record its times, how many times for this point. Only this times frequency gets to 0, we are able to remove from our data structure. So for every event, right? For example, there are many events happens here. We need to compare, get the highest record in the tree map, which is the last entry method to get the highest one, right? The thing is that there is another thing is that it's possible for this kind of because for every rectangle or building, the left side edge and the right side edge, the enter events and leaving events happens, we need to calculate its highest. But since it's possible the highest points doesn't change, right? If it doesn't change, for example, there is a building in here, but there is a new building entering here, right? If it doesn't change, then we don't need to record this kind of point, right? So after this analysis, we just write code. First say is that we need to convert those kind of buildings into points, or we can call events, okay, equals new array list, right? And then for int b buildings, what we need is we have events add. So for the left edge, right, we just use int, for example, b0, the height b2, and we use 1 as enter events, and events add new int. So b1, this is right edge b2, and we use a -1 as a leading events, right? And let's sort those kind of events by the time. Compare per comparing int as int a goes to a0, right? And we can put compare with timestamp and then flag, for example, leaving events. We can also and then entering events. We can also put then comparing int. But actually for this one we don't need, because we need to calculate every timestamp, right? We need to, for all of the timestamp, we need to calculate, right? So that means for example, there is point here, right? And there is a leaving, some leaving, and also entering, right? So we need to calculate all of that. This is a positive flag. This is a negative flag. We need to well, before we move to the next point, some kind of event point, right? We need to calculate all of the events. So if we don't sort by the second the flag dimension, it is fine, right? So then what we do is that we need to have tree map, and we have the integer as a point, and also this integer as the frequency, how many times it appears. Call map equals new tree map, right? And the thing is that sometimes we want to see the floor key, the previous key, or whatever last key, right? It is possible here, right? There is no events, or at the beginning there is no events, right? No events happens. In that case, this map is empty, right? But the thing is that if map is empty, right? Of course, we cannot call the method like a last key or last entry, right? Because it's null. So to avoid this kind of scenario, we can put some kind of dummy data. For example, map put height 0, and also it appears once, whereas So let's have int n equals events dot size, right? And we can have a pre, which is Paris heights for the previous time events, right? So every, for example, we have, for example, we sit here, right? If we are here, what is the pre, right? Pre is still here, right? And if we see here, the pre is this one, right? Is for example, if we are at 20, the pre is 10, right? So that we only when the current hits and the pre hits they are different, will add it to our result. So we have list of integer as results because new array list. So what we do is that for int I equals to 0, I is smaller than n I plus plus, right? So we are going to have current point, right? Is or whatever we can call event or point. List get I. Um, so we need to add or remove it from our map, right? Map merge. So P0, P1, right? That is height, and P2 is the flag. That is we add or remove, right? We have integer dot sum. So the thing is that if it is a removing flag, right, it is possible this kind of P1 counts change to 0, right? So we'll say if this kind of map get P1 equals 0, we need to move it from our map remove P1, right? Then what we do is that we just use a group iterations. So if I equals n minus one, all the timestamp change, right? All the events. This is not a list. This is called events. Events get the time changed, right? Get I plus one there. Then let's check the current height equals map dot last here, right? So we'll say if current doesn't equal to 3, then we'll add to our result. So our result should add list of this time and our current x, right? And also, if it changed, right, then we'll set a pre equals current. In the end, we just return result. Buildings. Python code is similar, right? But if we use Python, the thing is that delete is also when we delete, for example, pick or pop, those kind of harvest the biggest data from the heap, right? We should still not only pick or the things that it's possible we need to delete some of the points in the middle, right? So we need still call the heap file. That is ON operation. So we can still also use the sorted dict, right? To use the sorted dict, we need to import sorted containers, import sorted dict, right? Then we are going to convert this kind of buildings left left edges and right edges as points or event, right? So for B in buildings. So what we do is event append by B. So for example, B0, B2, and has enter events, and the events append that is B1, B2, and a -1 as a living events. So we are going to have an event sort, sort by key equals lambda x by x0 should be enough, right? And of course, you can sort first by time, then by flag. But done the sort by flag, it is fine, right? Because we need to calculate for the same time step every event before moving to the next, right? So so we need a sorted map, right? We call it heights. Heights equals sorted dict. And the things that we can also put a height 0 appear one times into it, right? And the result equals this. We need a print what's there, right? So what we do is that we do iterate for I in range length of events, and we'll say we'll get for example for example we have time, right? Time height, and let's call H, and also flag, right? Flag is entering or leaving. So that will be events R. So we'll have heights. Have this height should be heights get H. It may be 0, right? So we should add D, right? So it if entering, we'll add one more time. Leaving, that will -1. Right? So we'll say if heights H equals 0, that is only when D is the -1 flag. Then we'll just delete heights H. Right. So that means that we'll say if I equals length of events, or I equals this one -1, right? Or events I 0, the time changed events I +1, 0, right? Then we're going to have current equals the heights peak. So this sorted in Java we use last, right? So but Python we call pick item, and we pick the last one. We use -1, right? And in the for this map, the first one is its height, right? So we'll say if current plus equal to 3, then we'll have result should append at this kind of time and the current. Then we'll set 3 equals current. In the end, we just need to return result. This is not D, right? This is called a flag. Did I use any D flag that is entering or leaving? Okay. So the time complexity, right? Time complexity, it will be n log n, right? No matter that is entering or leaving, we are use a tree map or sorted disk. So it is those kind of operation is log, and there are n points, or will every be n building that is to multiply n points. So that is n log n in the space, right? So those kind of data structure or collections or map or whatever, it is linear data structure. So it is all in space complexity.